So this system is very similar to the first one. In this case, though, it's not the costs for seeing certain numbers of movies with the past. This is the cost for a couple of different options to replace or repair a broken lawnmower. So imagine you've got Peter. He mows lawns to earn money during the summer. This is actually exactly what I did when I was in high school and college. And his lawnmower breaks down. He wants to keep on mowing lawns and making money, and he's trying to decide which is the best option, to repair the old mower or to completely replace the mower. And so his options are, first of all, he could pay 160 bucks, kind of a cheap option to get your mower going again. But that's a old inefficient mower, so it's got maintenance and repairs and fuel costs and stuff. So it costs him, whatever rate he's mowing lawns, it costs him $45 a week to keep that old mower running. Option B is to splurge for a new mower, a new energy efficient mower for $400. So it costs a lot more up front, but then it's going to cost only $15 per week for fuel and maintenance. But doesn't need as much tender loving care to keep it working, and it also doesn't consume as much gasoline to keep it running. So it costs a lot less each week. So the question is, how many lawns would he need to mow to make that more expensive option, the new mower, pay itself off? Because notice, if you look at it, to buy one, it costs $240 more to buy it than to repair the old mower. But then every week you're saving $30 in fuel and expenses for maintenance. And so at some point you're going to mow enough lawns that that new mower would pay itself off. And the question would be, are you going to mow that many lawns, pay it off? Or are you just going to do a little bit more mowing and then maybe it's the end of the summer and you're going to be done with it? Maybe not doing the same thing the next year. So do you want a short-term fix or a long-term fix? And how many lawns does it take for one of them to cost more or less than the other? So again, going back to the table, just to get an example of this, because remember, making a table and doing this calculation also helps you write your equation. Once you see what that repeated calculation is to calculate the total cost for some number of lawns, you can see what the slope-intercept equation would be to represent that pattern, and that makes it easier to put on a graph. Or in the next investigation, I'll show you how to use Desmos, a program, to type in your equation, and Desmos will show you what the intersection point of that equation is with another on the graph. So for the first one, option A, this is the one where it costs $160 to repair the mower, and then it costs $45 each week to operate that mower. And so as I do my calculation, if he was to repair it and then not mow any lawns, it would cost him $160. If he mows one lawn, it's going to cost him $45, or sorry, I should say a number of weeks. I need to fix these actually. Okay, I fixed my typos. So I had number of lawns instead of number of weeks. So remember, it costs $45 per week for the old mower, and it costs $15 a week for the new mower. It's not $45 per lawn and $15 per lawn, it's per week. So we're trying to figure out, are there enough weeks left in the summer lawn mowing season for Peter to justify repairing or buying a new mower? So it just depends on how much time he sees left in his yard work season. So anyways, so if it costs $45 for 1 week, plus $160 for the repair, if he was only going to do 1 week, it would cost him $205. For 2 weeks of mowing, it would cost him $45 for each of those weeks. That's $90 in expenses for fuel and maintenance, and then $160 for that repair that he had done, so that'd be $250, and so on, down to, I went up to 20 weeks. Notice I did the same numbers for each again, so I could kind of compare. So at 20 weeks, it would be 20 times 45 plus 160. So the equation that I'm using for this first one would be y equals 45x plus 160. And then you can see for option B, it costs $400 for the mower. So if he bought that mower but didn't have any weeks left, it would cost him $400. Then it costs him $15 each week. So $15 for 1 week plus the 400, that's $415 total. If he was to do this for 2 weeks, that's $15 times 2, plus the $400 for the new mowers, that's $430, and so on. And I went up to 20 weeks on that one also. So the equation for this one that I'm using is y equals 15x plus 400. And you can see on this one the point where they swap again, just like we did for the MoviePass problem. You can see that it looks like it's somewhere between 5 and 10 weeks. Notice they switch. So at 5 weeks, it costs less to repair the mower and pay more per week to operate it. So $385 there. Versus the new one, it still costs more to buy a new mower and operate it for $15 a week for 5 weeks. But notice I skipped from 5 to 10. So notice at 10 weeks though, it costs more to use the old mower repaired than it does to buy a new mower and run it at a cheaper cost per week. So it's different by about $50 or $60. And it stays that way for the rest of it. So 15, 20 mowers. Notice by the time you get to, or 20 weeks, I should say. Notice by the time you get to 20 weeks, if this was like the very beginning of the lawn mowing season in like March or April or something like that, you know, the whole months of spring, summer, and into fall to do mowing, notice how much different the costs would be. It'd be over $1,000 to run the repaired mower. It would only cost $700 to buy a new one and just run that more efficient mower. So if this was in the spring, you can already tell, you don't have to do any more math, but it makes a lot more sense to buy the new, more efficient mower than it does to repair the old one. It costs a lot more to operate per week. So we know though that the crossing point when we graph these should be between 5 and 10 weeks. So now going to the graph, I'm using that same shortcut where I just graphed a couple points for each pattern because I don't need to graph every single point. I know if I graphed all the points for each pattern, the green points would all fall in a straight line and the blue lines would all fall in a straight line. I don't have to make every little dot. I can save myself a little time. So for option A, I've got a dot down here at 0 weeks of mowing and $160 for the repair fee. That's the y-intercept. And then for option B, the $400 replacement mower at 0 weeks, be up here at 400. And then I graphed my cost at 15 weeks of mowing for both. So all I have to do is use my ruler and connect those dots. And I'm just looking for the intersection point. We know about where that should be. So there is option A. And there is option B. So remember, this gives me an estimate of the solution to the system of equations, because if I made a sloppy graph, then the intersection point isn't necessarily going to be exactly where it should be. If I made a really, really careful graph, and this is pretty careful, then my intersection point should be pretty close to what the actual number of weeks and the cost would be at that point. So there's my intersection point. That intersection point looks like it is at 8 weeks. And it looks like it's about, well, it's between 500 and 550, so I'm going to say it's about $525. So I've got a pretty good estimate. And so we already know now, without doing some calculations here, that if Peter has 8 or more weeks left in that lawn mowing season, so that's a couple months, then he's better off buying the new mower, which is more expensive because it's going to pay itself off in saved costs per week. If he's going to mow less than 8 weeks, so down here, notice the green line is below the blue line, so option A is cheaper than option B, below that intersection point down here to the left. So if it's less than 8 weeks, if it's getting towards the end, he might just be better off repairing the mower. It's kind of inefficient, but he's going to save a bit of money. And if he mows lawns the next summer, that would be the time maybe to decide whether or not to buy a new mower. But past 8 weeks, notice the green line is above the blue line, which means plan option A, the repair, costs more than option B, the new mower. And the last thing is, remember the graph gives you an estimate of the solution of the system of equations. So the last thing is to actually calculate if you actually got the right intersection point. So see that you got approximately the right point. So if we were to do for option A, if we do y equals 45 times 8 plus 160, that equals $520. And for option B, if I do 15 times 8 plus 400, that's $520. So that is the correct solution to the system of equations. On my graph, I was off just a little bit, but remember, a graph is giving you an estimate that is as good as your graphing precision and skills are. Whereas an actual calculation, and if, let's say this calculation was off just a little bit, it just means that I need to try maybe 9 or 10 or 6 or 7. I know that it's somewhere in that ballpark in between 5 and 10, find that exact number of weeks.